Hi, here's another practice problem with integration by parts using the definite integral part 2. First, I understand that there's tons of tutorials out there, therefore if I can't be a help, then I'd highly recommend you check out Professor Leonard, who was an extraordinary supplement to my calculus classes, Professor Dave Explains, Organic Chemistry Tutor, Patrick JMT, and such. I will probably leave links in the description below for you to check out. I am fully aware that I may not be able to reach through to every single person watching this. I'm definitely not proclaiming that I found a breakthrough in teaching. I haven't. I just simply want to help out the best I can, and teaching is my passion. Okay, so let's get started. So we have the definite integral from integrating from 4 to 9 of ln of x over the square root of x dx. It's important to note the formula for integration by parts, which I derived in a previous tutorial. It goes that u dv equals u times v minus the integral of v du. And there's a slight amendment to this, or modification to this, when you're dealing with the definite integral. The definite integral goes from a to b, so if you have such a definite integral, then the answer is going to be uv integrated from a to b minus the integral of a to b v du. Okay, notice that this is actually a product. Looks like a quotient, but it's a product. It's ln of x times 1 over the square root of x dx, but they just multiplied together. Hence it's a product, so we get to use integration by parts. We want u to be something that we could differentiate easily, and dv to be something that we could integrate easily. So one part of the integrand here is u, and the other part is dv. And we're going to let u equal, now can we integrate ln of x easily? Well, I actually have a tutorial on that, and it's really not a simple answer. So you have to use integration by parts to integrate ln of x by itself. So we should let u equal ln of x instead of letting dv equal ln of x. dv is going to equal everything else. Well, first of all, rad x, I'll write it right here, is x to the 1/2. Now since it's in the denominator, I'm going to raise it to the numerator by negating the exponent here. It means the same exact thing. So I'm just going to have dv equal x to the negative 1/2 dx. Okay. Now du, now we differentiate. Okay, the u, the derivative of ln of x is 1 over x dx. And the derivative of v, using the power rule, okay, with the fraction, this is how you do it, which I'm sure that you probably know by now. We take the exponent and we add 1. Okay, that's 1 right there, it equals 1. And we divide it by the exponent plus 1. And when we do so, we have x to the 1/2 over 1/2, which equals 2x to the 1/2. Okay, so v equals 2x to the 1/2. You could put rad x if you want. So now we just do integration by parts, u times v minus the integral of v du. That's why I set it up like this. So this whole thing right here is the integral from a to b u dv right here. And we chose what our u was and what our d was from this integrand. And this is going to equal, okay, what we chose for u and what we solved for v times 2. I'm just going to put the 2 right here. X, I'm just going to put rad x right there. Means the same thing. And that's integrated from 4 to 9. And then I'm going to subtract from the integral from 4 to 9 v du. Okay, that 2 is a constant, so I'm going to pull that out. And we're left with x to the 1/2 over x. dx. Okay, so instead of doing just this part and then solving this part, I'm going to do two things at the same time. I'm going to start solving for this while I'm going to be solving for that. So this equals, just using the fundamental theorem of calculus, part 2, it's 2 times ln of 9 rad 9 minus 2 times ln of 4, natural log of 4, times rad 4. Okay, and then that quantity right there is being subtracted by 2 times the integral from 4 to 9. Now we could simplify this by subtracting the exponents right here. And to do so, that's x to the 1/2 minus 1. Okay, that equals 1. So that's x to the negative 1/2. And that's what goes in here. Okay, now let's further simplify. Now that's the radical 9 is 3. So 3 times 2 is 6. So 6 natural log of 9 minus, that's 2. 2 times 2 is 4. Natural log of 4 minus 2 times, now the integral of x to the negative 1/2 is the same here, the same thing here. So I'm going to multiply that by 2x to the 1/2 integrated from 4 to 9. Okay, so that's going to equal 6 natural log of 9 minus 4 natural log of 4 minus, I could go ahead and pull that 2 out, and we're left with, that's the same as radical x. So that's radical 9 minus radical 4. That's going to 3. That's going to 2. And 3 minus 2 is 1. So that's 4 times 1, which is 4. And so we're left with 6 natural log of 9 minus 4 natural log of 4 minus 4. We don't need the c, the constant of integration, because it's a definite integral. We're actually arriving at an answer, and that is a valid answer. I'm sure your teacher's homework will accept that, and if you're like me, you're so tempted to simplify. So if you're satisfied with that, you could go ahead and stop the video now. Okay, so for those who are still here, I just am tempted to simplify this further. I've actually simplified this with down to a decimal, in fact, which I'll get to. Using the property of log and natural log, this 6 could be pulled up here, okay, and this 4 could be pulled up there. So you're left with the natural log in 9 to the 6 minus the natural log of 4 to the 4th minus 4. And using another property, you see that subtraction there. So that makes the argument a division, a quotient. 9 to the 6th divided by 4 to the 4th minus 4. And you could simplify that further. You will get approximately 3.64, and on it goes. And that's another answer. Of course, you could just put that in the calculator, but sometimes, if you're like me here, just so tempted to use as much algebra as you want, or so. That's if you like algebra like I do. So, but whether you like this or you're just thankful that you just got this far, it just takes practice. I could definitely say how practice is very key to do this. So whatever your plans are, whatever your major is, why you're taking this class, whether it's medical, whether it's engineering, or whatever you're doing, if it's truly in your heart, don't give up on your passions, and have a nice day.